Okay, we are into reduction formulas. Basically what it's all about, sin, cos and tan are ratios, and we've seen that they make a pattern. The patterns you can see from your graphs, that they actually do the same thing over and over again in these specific patterns. Now I'm teaching you the stuff to simplify. Just like in algebra there are rules to simplify, also in trigonometry there are rules to simplify. So then when I want to work with this, I need some reduction formulas. So the first rule I told you was right. So we have reduction formulas going back to simplification. So all of your degrees that you're going to be working with, you want to reduce back to the first quadrant. But then there are two ways of asking the question. I can either work with actual degrees, or I can work with our unknown variables, theta, alpha, beta, and A, B, C, doesn't matter. They normally like the thetas and the alphas and the betas in the trigonometry. But then that's it. But there are rules. So the first rules that we already now know, and we're going to get to getting them all together in one sum. Because you will not get a sum like what I'm doing at the moment and what we've been doing for the last 2 days. Those are just introducing you to the techniques. So when I talk about reduction formulas, the first thing that you know is if the angle, and there's nothing like that on the board, if the angle was like 165, you reduce it back to a acute angle. How? You have three missions. 180 minus, 180 plus, 360 minus. That's always going to be your go-to, your first step. Then if your angle is larger than 360, what do? You just subtract as many as you possibly can to get from wherever you were on the graph back to the first 4 quadrants. And if you're back in the first 4 quadrants and it's not an acute angle, you again do the reduction formula. If it's a negative angle, you actually, on the axis, on the left-hand side of the x-axis, so you've also got to bring it back to the positive side, and there are rules. Let's see if you can remember the rules. So for a negative angle, you make the angle positive and the ratio
negative except for cos.
Excellent. Alright, special angles is nothing new. Special angles you are supposed to know that sin of 30 is a half. Cos of 30 is root 3 over 2. But how are you supposed to know that? Either you do it on the calculator, you know on which position you are in your life for all the sorts of stuff that you need to be able to do it without or with a calculator, or you need to know those little triangles or any other technique. Nobody wants to know your technique, I just want the answer. Okay? Special angles. So whenever anything is reduced back to 30, 60, 45, and what else? What are the other special angles? 90, 180, 270, 360, and even 0 as well, right? Then you're supposed to know it. How are you supposed to know that? By knowing your graphs. If you know your graphs, you'll know exactly where those points are. And for 45 on the tan graph, you also know a very specific point because that's the one that you keep sketching all the time. That tan 45 is 1. Excellent. So that's how far we've come. The fifth thing, and there are 6. The fifth thing I need to teach you are cofunctions. So I've told you when you have a choice, you are going to choose for the second quadrant, you're going to choose 180 minus, and for the third,
180 plus.
so for the fourth,
360 minus.
and that will not change except for exceptions. In general, when you get a question that's got 150 degrees, you use that. 200 degrees, you use that. 300 degrees, you use 360 minus. We call this the function axis. And that's what you're going to do if all else fails. But there is something else that's in the syllabus that I must teach you, and those are the cofunctions for a reason, because they're going to help you. So I said to you in the beginning, it should have bothered you that I say 180 minus, and why can't I say, this is 90, right? Why can't I say 90 plus? Because you can, but you don't. Okay? And even here, you're going to be working with an acute angle, right? So who wants to change an acute angle to something else? There's going to be situations coming up. Remember, we're getting into the bigger picture. there's going to be situations where you can then say 90 minus, because it's 90 minus whatever. Are you with me? And even here at the bottom, this is, so you can have 270 minus and 270 plus. Now those four things are called the co-function reduction formula. But the only things that are in the syllabus that I can force you to work with is those two. So, never. And how will I force you? Because if I ask you for 100 degrees and you say 90 plus, I'm going to kill you if you don't do it right. If I give you 100 degrees, what are you going to choose? 180 minus. So then why do I teach you this? Because I'm going to force you. I'm going to ask you something like this, which is syllabus, and then you've got to know what to do. But I cannot ask you cos 270 minus or plus. That's not syllabus. If you know how to work with it, I can't stop you because it's actually the same principles I'm going to be teaching you now. But in a test, I can only force you to be able to work with those. Are you with me, guys? A little bit?
Yes, ma'am.
Now, the easiest way to show you why we need this or how we're going to need this, I'm not going to go here first. I'm first just going to show you inside of a triangle. I'm saying sin of 20 degrees will be the same as cos of something else. Now, how can this happen? All right. Co-functions are, let me do a few things here for you. The co-functions are, and then I need to write it like this. We're not talking about how sick we are now. Sinus is actually the correct word for sin. It's the sinus graph or the sinus ratio. Then there's a cosinus. What do you see? Co. Right? And that's all that we're going to be doing. But let's be nice and complete. If you have tan, the actual word is tangent. And that becomes? You see the co? You're not going to do that. I'm just being complete. Then even there was other stuff that should be bothering you that we're not doing in grade 11 anymore. Sin cos tan? Cot? Sec and cosec, right? Now sec is actually secants. So then this will be cosecants. Do you see the cosec? Now originally in the syllabus you had to work with all of them, and it's not that we're throwing stuff away, but you can get by just by using sine and cos, because you're going to be seeing later on what I'm talking about. Because sec, right, is the inverse of cos. So whenever you see sec, which you won't in a paper anymore, but if you do, you just make it 1 over cos. If you see cosec somewhere, you just make it 1 over sin, but then you've got to know which one is which, right? And cot, you just make it 1 over tan. So you can get by without these. Now I'm talking about the co-functions. Sin, its co-function becoming cosin, in other words cos. And just as well, cos can become sin. They are the co-functions of each other. Tan, we are working with tan definitely. But tan, I'm going to teach you a new identity, which brings it back to sin and cos again. So actually, we're always going back to sin and cos. So we have combined all of the information into being more little easier just by going back to sin and cos, because even tan goes back to sin and cos. All right. Now you know that the sin graph and the cos graph are very similar to each other. If you look at the sin graph and you look at the cos graph, what's the difference? So if you move it, what's the difference? How much must you move this to get to this one? Or move this to get to that one? 90 degrees. 90 degrees. 90 minus. You remember that boys and girls go left, go right? But if you're moving it by 90 degrees, you get from sin to cos or from cos to sin. And that's actually what it's all about. You don't have to know that. After now, you're just going to have to know the rules, but I want to teach you this. This is also the reason I can't tell you that this is the sin graph. This could have just as well been the cos graph that moved. And this could have been the sin graph that moved. Are you with me? So now, if I want the sin of 20 to become the cos of something else, what must the move be? Something with 90, right? Okay, but let's make it easier for you. Let's look at a triangle. So you see, there are so many angles of seeing these things. If we look at a triangle with 20 degrees, it doesn't have to be on an axis like we did with our butterfly. If this is 20 degrees, this has to be 90 degrees. What's this thing? So now let's check this out. So the sin of 20. I don't know what the numbers are. I know what the ratio is because the calculator will give it to me. So I don't know if this length is 20 or 30 or 80 or whatever, but the ratio between the opposite and the hypotenuse will be the same. Doesn't matter how big or how small it is, it's all about this 20 degrees. If we want to erect some building here, and all I know is I know the distance here, and I know how long that must be, then this angle over here will be a very specific angle. Whether I build the building closer to me or not, the angle, it's all about the angle. It can be a small little triangle, it can be a big triangle, and that's why when you go for engineering and stuff, you need to know your maths to be able to calculate exactly to the thousandth digit how exact that measurements must be so that your building doesn't fall down and the bridge doesn't collapse and so on and so on. So if this is then 20, it makes sense that that is 70, right? But tell me, if I call them, let's call them ABC. So sin 20 will be what? In terms of ABC? B over A. Do you agree? But what is also B over A? Cos of? 70. Because if you're standing there, this is your adjacent and your hypotenuse side. And then that means they have to both add up to 90, and it's something crucial forever for trig. When we're in a right angle triangle and I ask you, listen, if this is 30 degrees, what is that one? Please don't go and say 30 plus 90 is 120, take it away from 180, because that's going the long route. The easiest way is if that's 90, then they have to add up to 90, so it's easy to see that that must be 60. Are you with me? And this is crucial. So if I want to change sin of an angle into cos of an angle, those two angles must add up to 90. So what must be here? 60. Sum is done. This is not a sum for a test, okay? It's going to be inside of a sum. So help me quickly tell me, if it's sin 50, it will be equal to cos? Excellent. Can you see it happening inside of a triangle? If this is 50, then this has to be? And the one's sin is the same as the other one? Cos. But only sin and cos. Do you see I'm making a little note here for you, a little summary. It's only sin and cos. Because I've told you, we're not going to go for tan because you're still going to find out that tan is sin over cos, so you're going to go to sin and cos anyway. So it's all about sin and cos. So if I want last one with degrees, so if it's going to be cos 65, it's going to be? 25. You're just going to make sure that you add up correctly and don't say 35 or something like that to get up to 90. Are you with me? Now, actually, guys, you should have said cos 90 minus to get to what I actually want to show you, because we can't do what we just did with this. We can't do what we just did with that. If it's degrees, then no problem. So if I want to write it with these reduction formulas for cofunctions, I need it to be 90 minus and 90 plus. So then if it's 65, it will be 90 minus what? 35. Are you going with me here? Now I'm going to teach you about magic. Poof. But not only poof, it's going to be poof, puff. It's very mathematical. No, it's not. I teach it to you this way because kids remember it this way. Okay. So you know how to poof already? Yes. Now this is going to change because you're seeing that sin is changing into cos and cos is changing into sin. So I'm helping you to say, if you did, the answer's right. I just want to show you, if it's written like this, you're going to go. The 90 minus part is going to go, poof, gone is it? So 35 is left. Are you with me? Yes. But then cos is also doing some magic. Puff. It's going into sin. Oh, not 35, 25. Now I made a mistake, sorry. Are you with me, guys? Yes. Okay, but when it's degrees, no problem. Easy. Sin 10 is cos 80. Sin 45 is cos 45. Are you with me here? You're always going to do that. But now we've got to get to the actual more technical academic stuff. So if I have it, and I'm going to erase this, okay? You don't need to know all of those grand names. So if I ask you an equation, because this is going to happen, your sum is going to be like 6 marks, and you're going to have one of those, one of the previous ones, negative angles, all of them together in one sum. If you see 90 minus, you must think poof pop. Are you with me? If you see 180 plus, you must think poof poof. If you see 90 minus and plus, poof pop. Are you with me? Please don't forget that there are others, but you're not using them. And if you know how to use them and use them correctly, I'm happy with you, but then you mustn't make mistakes. So, tell me what to do. First we go, poof. So what's gone? 90 minus, guys, including the minus. 90 minus is gone, so it's poof gone. And then? Puff. There you go. That's it. Do you see it? If you look at the degrees, that's exactly what happened to the degrees as well. The only way I can show you that it's actually true is with the degrees. Punch into your calculator cos 65, see the answer, whatever it is. Punch into your calculator sin 25, it's exactly the same, so that you can believe what I'm telling you. So let's go for the next one. Okay, no, let's not go for that next one. Let's go for G first, because I still need to show you something else. We're going to go poof here, right? And it's just going to be theta, puff. But now guys, what about the sign? All of the time when we did 180 minus 180 plus, we went poof and check the sign. Poof and check the sign. What about the sign here? Which quadrant are we in? First. Guys, when I say 90 minus, you must know that's first. Whenever I say 180 plus, where are you? Third. If I say 360 minus? Fourth. If I say 90 minus? First. If I say 90 plus?
Second.
Are you with me?
Yes.
You mustn't guess. You mustn't wonder. You must know that I am now in the first quadrant. And this is the reason for these first two that I've just done. I didn't even look at the signs, because in the first quadrant, what are the signs? All positive, so no problem. Okay? So then, what happens to 90 plus? Where am I now? Second quadrant. All of them are not positive there. Here's the trick. So we go. Tell me. Poof. And? Puff makes it sin, right? But what about the sign? Because we're now in the second quadrant. Now, I know you're going to do it wrong, so let me help you. Sin is positive in the second. This is not a positive answer. This is a negative answer, because, follow me. You were originally in the second quadrant. You were originally busy with cos. And cos in the second quadrant is? So after doing the reduction, the answer must still be negative. I'm saying again, it's poof puff. You were in the second quadrant. Originally it was cos, and in the second quadrant cos is negative. So when you reduce it back to an acute angle, it's still got to be negative. It's about the original one. Original cos in the second quadrant is negative. That's why the answer is negative. But ma'am, sin is positive. It's not sin. It used to be cos in the second quadrant, which was negative. Okay, let's do this one and see if you get it right. Where am I? Second quadrant. So this is going to go poof, puff. So sin becomes cos. And the sign? Negative. Stays positive. Because you were in the second quadrant originally, sin, and sin is positive. And guys, for now, it might be a good idea to write that plus thing, so that you know you must check it all the time. And now we can complete our little box that we want to go study from. So help me. We go poof puff, right? So we say Poof and Peter. Purpose. Cause. Do we check the sign?
No.
Why not?
First one.
Because you're in the first quadrant. And if you want to check it, okay, then it was positive, it stays positive, so positive it is. This one will become poof. Peter. Puff. Sin. You're going to still remember this poof puff, I know. The only problem comes into the second quadrant because now it is poof, Peter. Right? And puff, cause.
Positive.
Are you sure?
Yes.
Definitely.
Yes.
You're right. Because in the second quadrant, sin is positive. It becomes back to the first quadrant, but the original one, that's the sign. This one's going to become poof, Peter, sin, puff, but negative because it used to be second quadrant cause, which is negative. Now, some people feel, ma'am, I'll just study this off by heart. Guys, it gets to be a lot after a while. You've been learning a lot of things. If you want to make up lists, your whole house is going to be full of papers that you're trying to just memorize. It's going to get rough. If you understand what you're doing, that'll be great. Okay, for interest's sake, let's do Am I allowed to ask you this?
No.
No? Can't ask you that. Okay, but if you do see it and you do want to do it, how do you think you're going to do it? The 270 plus is around the co-function axis. So the same rules apply. You're going to go poof, puff, and now you're going to tell me you were in the fourth quadrant.
Oh.
270 plus. So, sin in the fourth quadrant is? It's not about cos in the fourth quadrant, it's about sin in the fourth quadrant. That's just for interesting sake. Don't even write it down if it's going to confuse you. So now how am I going to force you to do all of these things? Inside of a sum, there can be something like sin 20, cos 150. This is what we're aiming to. Let's just do a random example and it might not work out nicely because man is just
Guessing.
okay. This is what we're going. Right. We're looking it right. And now all I'm going to say is what? Solve? It's not an equation, simplify. Okay, what's there to do? I don't see anything to do. Make it acute by saying 180 minus. I think I must erase it and start back up there so we can actually see what's going on there. Alright. So we said sim 20, we don't really see something to do here. So let's leave it 20 because the golden rule is everything has got to be acute. With the cos 150, what are we going to do?
Make it acute.
How? 180 minus. So we're back to the basics. Usually back to the basics if you have a choice. Could you have said 90 plus 60? You could have if you use it correctly. Please don't. Stick to 180 minus, 180 plus 360 minus as far as possible. If later on it's necessary, you're going to change it into co-functions. Okay? And then this one, now I've got theta again. It's just going to go, sorry? It's just going to go, just poof. Theta, cos stays cos. But, plus or minus?
Plus. Cos is always plus.
It's not a negative angle. It's in the third quadrant where cos is negative. So guys, you're seeing there's lots of information. This wasn't a negative angle. This is just poof. Cos in the third quadrant is negative. Now, the brackets. To help yourself, put everything you've got in brackets. even this in 20. Then you won't make mistakes. Because if you don't put the brackets, you're going to start subtracting instead of multiplication that it should have been. Tell me? Poof puff. And if you don't see it, you're going to do it wrong. You've got to identify it's a poof puff. So it goes poof theta, puff, cos, sine,
Positive.
y,
Because it's in the first
first
quadrant.
quadrant, no problem. Okay? And then what about 70? Also nothing.
Yes.
See what's happening? I'm not saying do it, but if you don't do it, you're not going to simplify. So you've got to identify, look at this. 70 and 20 together gives me 90. So the one can become the other. Which one? It doesn't matter. I've already written sin 20. So let me make this one sin 20. Now what's going to happen to it? So if you wanted to keep cos 70, you had to make this one cos 70. But you cannot just say, oh, I know it cancels out, and cancel them out. There you will lose them all. You have to show me that you know that cos 70 is equal to sin 20. Nice, you see it? Now I didn't have larger than 360 here. I didn't have negative here. But the things that I do have, I can go for now. So can I also cancel out the posits? Not quite. I first, in actual fact, have to go and do this. And say this becomes just poof cos 30, but in the second quadrant cos is negative. Now what about if I do this? There's something a problem. There's a negative missing. So just put it in the front. Are you with me? Cos can go into cos, but there is a minus in the whole scheme of things with the multiplication and division. So that'll make this become a plus. And guys, alternative ways of writing. You don't have to write it exactly the same way as me. And then this will be a what? Special angle. Which will be another mark for you if you know that the special angle. If this worked out to 20, you just leave it there. Right. Okay, you're going to do this for homework, but then you just have another look at one more example. So the sum will say what?
Simplify.
What is there to do? It's a whole lot of sin and cos and tan, all right? But step by step, what's this?
Supposed to be acute.
It must be acute, but first of all, it must be negative angle, but become a positive angle. You must identify it. So if you make the negative angle a positive angle, it's going to become just 315, right?
Yes.
What's the rule? Make the angle positive and the
Ratio.
negative, except for cos. So this must stay positive. And then what am I going to do with it? Make it acute by using 360 minus. If I use 360 minus, what's the answer going to be? 45. Now look at this. Can I do that? I would like you to very quickly get there. Knowing in my brain that it's 360 minus 45, and immediately going for 45. And I'm in the fourth quadrant where cos is positive. Perfect. For now, let's do 360 minus 45. And in the next step, say cos 45 with poof. And the first quadrant is positive. Are you with me? And then this is also a special angle. And cos 45 is? Okay, now please don't do it the way that I've just done it on the board. We do the sum as a whole, but I'm trying to show you there's all sorts of different things. What's happening here?
360 as much as
Larger
possible.
than a revolution, we take away as many revolutions as possible. And what's the answer, please?
315.
Okay? And then what do we do with 315? 360 minus 45, they look so the same, don't they? Okay. But what's happening here? This is, and if you are scared that you're going to forget, put it in big brackets. But don't start adding where you should be. multiplying, because it can be very technical. So this will then become, tell me, sin 45, right? Negative. What's wrong with this?
It's equals to 9.
If you don't put it in a bracket, this is wrong. Because now you're subtracting.
Oh.
Are you with me, guys?
Yes, ma'am.
Particular. And then we're going to have sin 45 there as well, with a negative. So it's going to be minus root 2 over 2. Okay? Rest of the sum. Cos 20. Oh, thank goodness I don't have to do anything with that for the moment. So then we're going to have sin 250. What are you going to do with it?
Make it a
360 minus 180 plus. 360 minus is going to be 110, then that's not acute. So you're going to have 180 plus 70. See something. 20 and 70. Coming. Are you with me? Okay, minus. So cos 20 will stay cos 20, but this will then become poof, sin 70, right? But positive or negative? Where are we? Third quadrant sin is negative. Are you getting confused? You shouldn't. Bit by bit. So it's poof 70, but sin in the third quadrant is negative. What's going to happen here? This whole thing, this whole term is going to become a positive. And then, what about this?
They would not cancel.
They can cancel out, and if you just cancel them out, I'm going to hit you. You've got to do what?
change it.
Show me that they're the same. If you just cancel them out, I know you're right. But this is a specific thing that at the matric end exams they say you don't give the mark if they don't show it. Even if I show, yes, I know it's going to cancel out. Minus a mark. Now you've got a choice. You can make them both sin 70, or you can make them both cos
Cos
20, which is the same thing, which will then be plus 1, not nothing. Are you with me?
Yes.
This answer then on a calculator, guys, the rest of it, calculator. Nobody cares about this calculation here. That was the big essence of the whole sum. So it will be plus a half if I'm right. Check. Okay, because this is going to be root 2 times root 2 is 2. 2 times 2 is 4, so it's a half, negative a half, plus 1 is a half. If you're working without calculators in NVT, you must test yourself and practice, okay? Last example. It doesn't look at all like this one, and none of them are going to. Every single little bit, you've got to say, is it negative? Is it bigger than? Is it special angles? Is it, what else is it? Co-functions. Do we have co-functions here? Yes. With the 20 and the 70, but it never said 90 plus, so that we went off. Because there are variations on them. Okay. J, B, and H. Try your best, guys.